Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Arjun Narayan, CEO of Materialize, a company building an operational warehouse, and Nathan Bean, who's a data leader at General Mills, responsible for all the manufacturing analytics and insights. I've been looking forward to this episode for a while, because we've been excited about operationalizing your warehouse and streaming analytics for many years. And I wanted to ground the conversation in a real company. We talk a bit about Materialize's founding story, how streaming technology has matured, and how exactly companies are leveraging their warehouse to operationalize their business. And as Tristan points out, this episode will tell you all about how data plays a role in getting cereal manufactured and delivered so you can enjoy your Cheerios reliably for breakfast every morning. So without further ado, let's get into it. Well, I'm really excited for this episode. We're joined by two guests. I've been wanting to do this episode for a while. We have talked about streaming on a number of episodes, but we've never really had the experts in the room. And so today, to join us to talk about the topic, we have Arjun Narayan, the CEO and founder of Materialize, and he's joined by Nathan Bean, who's responsible for manufacturing data analytics at General Mills. And I want to hand it over to the two of you to just give a quick introduction. Nathan, why don't we start with you?
Yeah, Nathan Bean from General Mills, about 25 years of work experience in the manufacturing segment, and more than 20 years with General Mills.
We're going to get into it in just a minute, but Arjun wanted to say hello quickly, and then 20 plus years at General Mills. It's quite impressive.
Yeah, thanks. Been a while.
And hi, I'm Arjun Narayan. I'm the co-founder and CEO of Materialize and been into databases for a while. Before this, I was at a different database company as an early engineer at Cockroach Labs. And before that, I did a PhD on distributed systems and databases at Penn.
Well, I'm really excited for this one. Nathan, do you want to just talk a little bit? Like, you've been at the same place for 25 years, always working in data. Has it felt like a lot has changed in that time? Has there been any very consistent themes where you're like, oh, we're always just still solving the data quality issue, or we're always still solving the timeliness issue? But what?
Julie, you're always fascinated by the technology, but we're skipping the headline that Nathan measures the creation of Cheerios, right? Is that a part of your job?
Yeah, absolutely. We're trying to focus on how to go from art to science when it comes to food manufacturing. Absolutely.
Are you responsible for making sure that, I actually don't remember if this is a General Mills product, but there are the right number of marshmallows in each box of Lucky Charms? Is there a chart that indicates this somewhere?
Yeah, definitely. And I'm obviously not directly responsible for that, but yeah, absolutely. We support those types of analytics for sure. Yeah, it's very scientific how we manufacture food, very concerned about food quality, safety, and we use a lot of metrics and data for that use case.
I'm just very jealous of people who get to come in on Monday morning and check dashboards, and those are the dashboards that they're checking, because my dashboards in comparison are really boring. They are SAS metrics, and serial metrics sounds way cooler. Okay, we can talk about technology, but I just wanted to acknowledge that that's pretty sweet.
Yeah, I would say manufacturing is a very cool environment to be in. There's a lot of complexity, a lot of challenge, but it's also very satisfying because you get to see something made every day and you're impacting that. So it's pretty cool.
And Tristan, I wanted to mention this. It's maybe my most interesting fact for you. General Mills was the first originator of the terms dimension tables and fact tables back in the 1960s.
Seriously?
Is that right? Wow.
Predates Ralph Kimball by about a decade. There was a research study.
How did you know that? That's what a random fact for you to know.
I've been saving this fact for this moment when we have the right audience to truly appreciate this fact. It goes back to Dartmouth and General Mills doing some of the OG data warehousing ever. And they came up with the stuff. And of course, I think there's, from that point onwards, there isn't the clearest citation trail, because I don't think these things were being properly published in the 60s, but that was the hands-on place where they did dimensional modeling for the very first time.
Very cool. Julie, I interrupted your flow, and I'm sorry about that. But you were asking Nathan about the changes over the course of 2 decades.
Yeah, it sounds like data is just like in the DNA of General Mills, and it's like kind of the lifeblood of the company. We just learned that it's even more ingrained because you invented dimensional modeling. But how has that changed in like your time, it being at the company? Does it feel very consistent to you? Were there like step function changes, like cloud? I want to hear a little bit more about that journey.
Yeah, and I definitely think there's been a progression. It's hockey sticked in the last 2 or 3 years, I would say. But in my tenure, like about 10, 20 years, as I mentioned, we've been very lucky to have a lot of data. The challenge is getting it out and getting it out of data silos and turning that data into information. So how do we contextualize that so it's actionable and it's approachable to our customers, our internal customers, folks on the plant floor, their support staff, their leadership, et cetera. So the consistency has been around, hey, there's a lot of data, there's silos. What's changed recently is how much the demand of what we need and how real time it needs to be. Where we see a lot of value is being able to respond to opportunities or issues in minutes, not days and weeks. So how do we take this digital thread or all of these thousands of signals, hundreds of thousands of signals off the plant floor and turn that into something that an operator, a mechanic, an engineer, plant manager can respond to? And that's really kind of been the new focus over the last few years.
I like to play the role in this podcast of like asking all the super basic questions that just because I'm curious about it. And maybe some listeners are not bored by my like very basic curiosity. A lot of early adopters for data technology are digital natives. So companies that often will deliver electronic goods and services. And as a result, appreciably all of the systems that run the operations of their business are like digital systems, like SaaS products and web analytics. We've all kind of understood, okay, you have a bunch of different SaaS data sources. You've got maybe some operational databases and they've got to flow into a data warehouse, whatever. But like, I don't have the first clue what it looks like to take data from a machine in a plant. How does that machine publish data to you?
Yeah, it doesn't. We pull it. So we have to kind of sample that data at a certain frequency. There are some paradigms and protocols that allow for it to publish versus being pulled. But for the most part, you have 10, 100 microsecond scan rates on a PLC, programmable logic controller, the kind of hard real-time hardware appliance. You can kind of think of it from an IT perspective. That's then pulled at 100 milliseconds, half a second, depending on the use case. And then that's published into a time series database. So you've got a lot of layers, a lot of latency, a lot of concerns about connectivity. So you have to deal with bad signals, late data, out of order data, sometimes even just bad, wrong data coming. And literally, we'll have use cases where we have hundreds of thousands of these signals. And when I say signal, you kind of think of a timestamp, a name, like a string, like tag A. We usually call them tags, and then a decimal value, usually. And just imagine those kind of streaming up off the plant floor. Then you have to bring them together to provide that context.
And so appreciably all of the machines that you deal with at this point do have digital connectivity. It's not like you're dealing with some behemoth that was made in the 80s where you have to like observe it from the outside or something like that.
We're lucky in them. I'd say 95%, I'm making up a number, like 80% of stats is made up. So about 95% of our unit ops are digitally native, I would say. And we do have patterns for some equipment that was we built back in the 60s, 70s. It becomes much more challenging, but I've been pretty lucky from that standpoint. Or you've got proxies, or you might use a proprietary protocol, or like even like RS-232 to connect to something that's more modern and then get it up into the database. Yeah, a lot of our infrastructure right now, at least the manufacturing portion, is on edge. It's on the prem because of latency for cybersecurity reasons. And so understanding how we leverage not only getting into that first landing spot, that first time series historian, but then how do we get it out for more end-to-end use cases?
Is that a really hard challenge? Like, I imagine you can't just like call Fivetran to sync the data from the machines to your time series database. What's that like?
Yeah, so usually with time series database, you'll have the timestamp, the name, and the value, and you land it. That's about as much context as you have. There are techniques out there around asset hierarchies, for example, to provide some additional context. There's mechanisms out there, software out there that will do stateful or stateless transforms. So like, hey, I want to go from Celsius to Fahrenheit. But when we go to stateful transforms, it becomes much more challenging. So in my mind, I kind of think of the historian as the place where we landed. We have history. And if you're a subject matter expert from the plant floor, you can leverage that data. But if you're not, then there needs to be another layer of contextualization to be able to make that information usable to a broader audience.
Manufacturing's been around forever. What's changed in the last couple of decades is just the digitization of it and the need to have more real-time operational use cases for how do you leverage that data. I think that's maybe a good introduction for Arjun too. If you can talk a little bit about what was the initial excitement and enthusiasm around starting up Materialize? Like, you come from an academic background, you're a PhD, you saw this tech, and fill in the story for us.
Thanks so much. Yeah. So I was doing a PhD at Penn, which is where I met my co-founder, Frank McSherry, who's now Materialize's chief scientist. He was at Microsoft Research, where he was doing a lot of distributed systems research. So some of the academic research predecessors to like Apache Spark and like Hadoop era. There was these projects called Dryad and Dryad Link, and they were fascinating. They were really the foundational stepping stones to all of these technologies that we're familiar with today. Sort of a tragedy that Microsoft Research never really commercialized that stuff and sort of led that, but they were definitely on the academic side leading things. Frank led a project called Naiad, which was a modern stream processing architecture that was scale out, distributed, and really capable of a lot of sophisticated streaming capabilities that didn't really exist prior to then, particularly around sort of stateful stream processing. And I was very, very fascinated with that. And I thought that was a sort of logical future, and I was very puzzled when like that wasn't commercialized almost instantly. That's when I sort of learned that in order for something to be commercialized, someone has to actually do it. This was news to me at the time. I had worked after my PhD at Cockroach Labs, which is a OLTP operational database.
What year are we talking about? Like when Naiad first came out?
Naiad won a Best Paper Award in distributed systems in 2013. So 10 years ago, a full decade ago. And that's approximately the sort of length of time it takes for something to go from exists theoretically in academia to is commercially available in databases and distributed systems.
Yeah, it feels like that time was really like the renaissance for when all of the cloud data warehouses and the new architectures were coming online. So you were really early then at Cockroach, which was also probably like a pretty nascent company back then. Is that right?
So Cockroach was based on a similar research database that Google had published called Spanner. And essentially Spanner is a distributed, scale-out, consistent database. So Mongo, in contrast, is if you rewind the clock back then, the future in sort of the late 2000s was NoSQL, right? Like the SQL was dead. This wasn't going to scale to your new data loads, and so you had to throw out SQL. And that was a narrative that the NoSQL world was firmly after. Data warehouses were dead too, right? Like you had to Hadoopify everything back then. Long story short, turns out there's a place for SQL in the modern world. In fact, it's far more ubiquitous than Hadoop ever was or NoSQL ever was on the OLTP side of things. And that's because of a lot of this research that went to systems like Spanner that were able to deliver at distributed system scale the same SQL we know and love that we've loved on sort of single node on-prem systems. So this was sort of the world in which I did my PhD and sort of was looking at these techniques. So when I went to Cockroach, what I really learned was sort of the commercialization arc of a new database and how long it takes to build a new database. That I think the rule of thumb is something like, takes 8 to 10 years, $100 million plus of R&D expense. That roughly, I think, still holds true. If you think of any sort of great database, so take Snowflake, that's also approximately how long these things take to get from initial idea or research paper to a production system that people can use and trust.
Do you think that we needed to go through the whole NoSQL movement in the early days of like large-scale cloud distributed systems?
No.
How did the universe kind of get started down that path? And like, why didn't it seem clear at the beginning that like data systems had been SQL based, they're going to continue to be SQL based for at least like the workloads that SQL is appropriate for?
Because a lot of people had Google envy. Google was at a certain scale. The thing that fundamentally broke a lot of these systems was these few internet scale companies who genuinely had orders of magnitude more data volume than anybody had ever had before. Right? If you take like inventory management system, right? Lots of companies have been selling stuff in buying and creating inventory management systems using traditional
And run
databases.
that out of Microsoft Access.
And what happens is when Amazon comes on board, right, and they have orders of magnitude more SKUs than anybody has had prior, because at the internet scale, this is great video from like 94 about why Jeff Bezos decided to sell books on the internet, because turns out on the internet you can have an unlimited number of SKUs, and books are the longest tail distribution of SKUs. But all of that just sort of breaks these databases. And once Google really starts trying to index every web page, right? So they ended up building correctly, in my opinion, bespoke systems that could scale for their workload size. The mistake is a lot of people who didn't have that problem copying their architecture because it was cool, right? So Google may have needed MapReduce, and I think they did. All the other people who copied Google saying that's the way of the future because Google is the future were making a mistake. And I think we generally accept that today. And there was a few people yelling about how this, Michael Stonebreaker was famously saying this effectively in like the mid 2000s. And since I would say being proven right.
So what we're kind of describing here is like we ushered in this like new modern data stack world today that people talk about, but it was mostly like batch and reporting. And what we heard from Nathan is like there's this real challenge that his team deals with having to have real-time information and digital signals that he can act on or systems can act on in real time. So we have both of you here today because we're talking about like streaming and real-time use cases. I'd love to hear a little bit more. Like Nathan, I know that General Mills has different systems for like batch reporting, analytics use cases versus more of the operational workloads. How do you split out like what goes where, what needs to be real time? How has the real time kind of operational decisioning changed General Mills maybe in the last 5-10 years? And was it like a technology challenge that you just needed better tools to do your work? Or like, why are we having this like new growth of real time and streaming now?
Yeah, I can speak to the manufacturing portion of General Mills. We're a pretty large organization, so we have different strategies for different personas or customers, internal customers. But as you kind of look at supply chain challenges, you look at competition, you look at a continued desire to grow, you start to get to a situation where your steady state opportunities or steady state losses are starting to diminish. And now you're looking for more transient opportunities. And what I mean by that is I need to be able to respond in minutes to an operative challenge on the plant floor. It's not running optimally. That could cost you a large chunk of change. So how do I not have to cold case that problem? How can I know right then and there that I need to go to the plant floor and observe? Better is versus having to go observe. We then feed that contextualized data stream into ML algorithms that allow us to provide recommendations to our operators, mechanics, engineers. And then the third tier would be, we're just going to send that recommendation directly back to the machine within obviously safety parameters and guardrails that it could actually adjust itself. Now, where those ML models need to be is a function of latency and resiliency. So that might be back in the PLC. It might be appropriate to do it in the cloud. But we kind of need that tiered approach of this real-time context to provide responses in minutes, not days.
Nathan, could you talk about like a very specific, we saw this signal in the data, we dispatched it to this person, and they went to the plant floor and they did the following thing. So many of our listeners including me, are so far away from this world that it would be wonderful to like take it into something really tactile.
Often the basics of manufacturing is you bring in ingredients, you bring in materials or different components, and it's just like you're in your kitchen, you're going to bake a cake. But instead of baking one cake, you're baking a million cakes, literally. So each of those ingredients has their own characteristics, right? Your flour might be coming from a different region of the world, right? Or it's certain attributes that we track, usually on a COE, certificate of analysis, to say this flour came into the building. Well, that is not going to be perfect. It's not like ones and zeros. They're not fungible per se. Each ingredient is kind of unique. And there's a capability of your equipment or your manufacturing line is that I can operate between 0 and 10. But if you give me an 11 or 12, we're in trouble. But you almost have a modality of how your equipment runs based on these ingredients and materials that come in. And you might have 50 ingredients or 10 ingredients that all have their own range, capabilities, or specification. And based on how those kind of overlay, the equipment needs to run differently. You need to adjust your set point. Like maybe I need to run a little bit hotter. Maybe I need a longer dwell time. So those are the kind of the examples that we're really focused on right now. Is you have a lot of external dependencies that have variation. How do you manage that variation so you still have a good quality product and you're still running at maximum or optimal throughput? And that's a very challenging problem.
I appreciate you taking us through that. I kind of just assumed that every Cheerio is going to be identical, but I'm glad to hear that there's a whole army of statisticians making sure that that is in fact true.
Yeah, there's a great organization too in our R&D. So we have food scientists that rock at this, and we've got support statistics and data science teams that all support a lot of this.
So you described like maybe two modes of response, one which was like different levels of an alert and a human has to go take action. And then the second case that you described, which is like full automation, where depending on what the data says, you'll have some ML system take instructions for your machines to take action without ever having a human be an approver or need to step in. How much of the work that you're doing falls into like the first camp of we're trying to just get the science down and our operations down to a really, really like great response time so that when things go unexpected, it's not a huge incident versus like, yeah, humans don't even need to be involved. Like we've built a fully robust system that can handle whatever we're seeing from the plant floor.
Yeah, that's a great question. So I would say we're primarily focused on the former, focused on how do we enable our operators and mechanics and engineers, because we need to create digital twins or digital representations of our line. So we have first principles. We understand the physics and chemistry of things, but that's only kind of one or two dimensional. How do we get that third dimension of how do we represent this manufacturing line and the product and material interface of that manufacturing line to a high level of confidence that we can then automate it. So we're kind of earning the right, and we're kind of think of these digital twins or digital representations as living documents to say, as we learn and we do experiments and DOEs, how do we start to codify what we've learned? And when we get the strong enough digital representation, then we've earned the right to feed it back to the plant floor. And it'll probably take years. But right now, instead of having all of these digital threads or hundreds of thousands of signals, can I get something that's at least actionable so someone on the plant floor knows where to put their feet to solve a problem?
This October, join data practitioners at Coalesce, the analytics engineering conference hosted by DBT Labs. It's built by data people for data people. Register at coalesce.getdbt.com with the discount code podcast23, just for our listeners. That's podcast23 with a capital P. We'll see you there. I mean, it seems like an incredibly complex organizational problem that you have to go solve because you have to be really responsive. But also you're making a big bet on the technology to perform and accurately give you signal and information so that you can do your job well. I'd love to hear a little bit more from Arjun. You've built a really robust real-time system that can help companies like General Mills take action in real time. What about the Materialize technology helps it be performant, easy to use, cost-effective? What of the secret sauce can you share that makes Materialize different?
If you take batch historical analytics, right? Like we take the modern data stack, but you've got these amazing, elastically scalable cloud data warehouses like BigQuery or a Snowflake, where you can write lots of complex logic that deals with huge amounts of data, can join them all together, very performant, simple to use, relatively speaking. You just write SQL, and the SQL can get really gnarly and complex, gnarly in a good way, in that it's able to express a lot of complicated business logic. And that's wonderful. The only downside is the latencies don't get very much better than ours, or you know, if you have meaningful data set sizes, maybe if you can really squeeze everything out of it down to double-digit minutes, right? And if you need something real-time, you have to give up all of this infrastructure. So you have to go to some sort of bespoke streaming pipeline stuff using Kafka or Kafka and Flink or a variety of these technologies, which are orders of magnitude harder to program. You have to essentially write a bunch of Java code. You don't have the flexibility of SQL. you don't have the operational ease of a cloud data warehouse, right? Like, forget about writing the logic and writing the program. You have this maintenance burden forever after keeping these systems online. And so most companies that I've encountered have this hard trade-off where when they have a real-time use case, they have to sort of hard switch from system A to system B and build a bunch of bespoke streaming infrastructure. And of course, because it's so non-trivial, this is restricted to the very, very few select class of use cases that are sort of existentially important to that firm, right? So most use cases that would benefit from being real-time or closer to real-time don't get to be real-time because the streaming team's already overburdened.
You're about to get to the like payoff from a Materialize perspective, but like, can we just for a second talk about the distribution of use cases? Because I feel like this is one of the most spicy topics in streaming. Like, you were talking about the modern data stack, which, you know, is historically pretty batch-based, and then this other streaming world, which takes a tremendous amount of effort. And so you only put a small number of use cases in this streaming category. Do you believe that, like, let's just say that like streaming were super easy? Are most use cases actually, like, batch is actually totally fine, and we don't need to think too hard about this whole streaming problem? Or are there really just like a million hidden use cases that we're just not doing because it's too hard today? I'm channeling George Fraser in my head from Five Train. It's like, no one really needs, I mean, like, some people do, but most people don't really need streaming.
You can divide things up into two categories, which is historical and operational workloads. And historical workloads are always going to be fine in batch. If you're dealing with primarily historical data and you're creating a report, you're reconciling something at the end of the day, you're reconciling something at the end of the quarter, there's no benefit whatsoever to move that to real time. In fact, I would say the majority of use cases where, like, is when you're trying to advance human understanding, batch is completely fine. Because if a human is trying to figure out, hey, should we focus our next campaign more in, did campaign A work better than campaign B? Should we throw more money at campaign A? That sort of strategic analytics, that is bread and butter batch and can be batch forever. Where time and latency matters is the two categories that Nathan talked about earlier, which is there's a live human who has to make a decision in a set operational process. So in Nathan's case, on a plant floor. They are on the plant floor, they are managing some machines, and they really benefit from seeing more signals. Or two, where you're trying to automate that, right? So I think of things like, and in the non-manufacturing setting, things that reverse ETL powers always benefit from lowered latency. So when we talk to our customers, if you're sending a activation email or a notification or something of that sort, the lower the latency, the better the conversion rate, right? So in any setting where you are triggering an automated job, lower latency is better. Now, of course, if it comes at such a high cost because you have to build a completely separate system, you might just be willing to live with that lower conversion rate. But again, to your point, if it was just as easy, I think every one of those operational use cases would prefer a real-time implementation. Again, holding the implementation complexity equal.
Which, like, is a huge number of use cases. Like, how many of the data points that feed into your company could you imagine triggering some type of messaging on? And the answer is, like, probably a lot. So anyway, this is like a little bit of a divergence, but many of us that have come from the world of data analytics or data science, we are trying to use our paltry human brains to understand the world. And we fall into that earlier category that you defined. And so I think it is really interesting that actually the other pond of use cases is like quite large and not well fished in yet.
Yes. And I think today the great restriction is on the implementation complexity. It's only those use cases. So take a financial services company, right? So fraud probably makes the cut to implement a bespoke streaming pipeline in order to do fraud detection, because fraudsters can steal a lot of money very quickly, right? That makes the cut. But pretty much everything else runs through a batch system. Of course, it depends what company we're talking about, depending on what resources they have available. But if it's not one of these, absolute tier one criticality use cases, typically today does not make the cut to have a bespoke streaming implementation. Then you have companies like Uber, right? Or more Silicon Valley native companies that are able to afford the expense and maintenance overhead of building an absolute large number of systems in a streaming fashion. Netflix is another great example, right? So Netflix's Flink team is maybe the best in the world and absolutely massive. I'd say pretty much every other company that's not in that bucket struggled to build some bespoke Flink thing and maintain it on an ongoing basis. Nor should they have to, right? So back to Materialize, the premise of Materialize is to give people a modern data stack-esque SQL environment in which they simply write SQL and they get all the benefits of a real-time, incrementally updating materialized view of that SQL as the underlying data changes, hence the name. And our thesis very much is that we want to stop talking about streaming, right? We don't want, you shouldn't be, the fact that we're even saying the word streaming is a bit of a bug. It's an implementation detail, right? Like what you want is lower latency for your SQL queries. The way we get that done is with an underlying streaming engine, but you should be talking about streaming approximately as often as you talk about B-trees, which if you're really interested in the implementation details, we can have a little seminar about B-trees, but how many podcasts have you had about B-trees before?
Hey, they come up.
This podcast.
But that's approximately as much frequency that streaming deserves. And we're not there yet, right? So as an industry, the only people who have been able to build real-time systems have had to go really, really deep, much deeper than we believe they should.
That's like an interesting observation. I think people talk about the tech at first because it's like you got a step function change and you're really curious about like how. But then once the tech is kind of relied on and used, you have this explosion of different use cases. Like we talked about, plant manufacturing. You also have an explosion of the number of people or the types of backgrounds that can participate in this workflow. So I wanted to maybe ask, Nathan, how has the makeup of the people on your team changed? Or like, where are you hiring to solve these kinds of problems today? People who host Flink or people that host, Confluent or Kafka, like these are usually like data engineers. You have to get very, very deep in the technical nuts and bolts. And these are like hard systems, like Hadoop, hard system, difficult to set up. But, SQL, really accessible. A lot more people can write SQL. And so I'm wondering, has the makeup of who's on your team, like what are their backgrounds? Are you able to get more people to participate, or has it been democratized in some sense?
So we definitely have a great support staff in our IT, or we call D&T organization, to support this type of workload, but it is challenging. The distributed nature, the fact you have to decompose business calculations into streaming operators is very painful. So you kind of have a specialty or a niche of folks that can do that tend to be quite a bit more distant from the domain. So what I'm looking for is how do we get the technical tooling, so like SQL, for example, love it or hate it, closer to the folks that actually live the life on the plant floor. Yeah, how can I enable them to solve $15,000 problems versus it need to be a $10 million problem before I have to then throw a distributed Flink or data flow structure at it?
Is that how you were doing it before, Flink?
Yeah, so coming back to, we were batched and we were leveraging relational data stores due to the nature of the low latency that we were looking for. On the manufacturing side, we've been a little bit of a lagging when it comes to leveraging cloud platforms because of the complexity and the latency.
Do you have like an expanding set of use cases that either in your domain that you're thinking about now because the tech has become more accessible and you're trying to get more people with the domain expertise in the flow? Or what is like the next set of potential real-time operational use cases at General Mills?
Yeah, one of the things I'm really excited about being able to use SQL. So maybe my data analyst or business analyst can start to partner with our internal customers more often is we've got thousands or hundreds of manufacturing lines, and those manufacturing lines have hundreds or thousands of questions they're trying to optimize for loss opportunities, throughput opportunities. So you can't have just a big bang solution. It doesn't work. You kind of imagine it's like the last mile problem that Amazon has. How do I catch that last mile? It's hyperscaler or it's hyper local. I also think of it that way. So I can't use a big semi to solve this problem. I need little mopeds. Those are the types of use cases of can we be agile enough so that I can just use SQL and have more of a batched or bounded mindset versus the mental anguish it takes to go to streaming. Can we reduce the complexity, make it abstracted away, make it an implementation detail as stated before, so that I can have hundreds of people working on digital representations versus a core group of niche experts. I'm hand waving because I think it's about agility. And as we see an opportunity, can I explore it with a group of individuals that are SQL savvy?
Yeah. And I mean, you've been doing this for a while. And I imagine that like agility and speed is really the differentiator for General Mills. And you have to get really precise and move quickly to keep up with the competition, but also just like continue to perform really well. Has that like intensity always, does it feel different now because you can do so much more with the tech? Or is that like, you just have to keep evolving your game over the decades that you've been working on this?
Yeah, I think it's still continuing to grow, and it's almost kind of like a loop of feeding itself. The more data you get, the more context, the quicker you get it, the more questions and opportunities you see, the more excitement you have, the more demand you have. So it's almost like this self-fulfilling prophecy of velocity, because we start to see the art of the possible. I think that's one of the challenges I have is understanding, here's what the problem statement is, what's the art of the possible? What can we do today? And what can we do tomorrow? And understand that the cutting edge stuff is tough and it's hard and it takes niche skill and it usually can be quite costly as you're figuring it out.
Arjun, I want to circle back to you for a second. You and I have been in touch for, I don't know how long, 3 years, something like that. And I've followed the Materialize story for that entire time because, I'm very excited about SQL powering more workloads. I think that the story of bringing data pipelines closer to, mostly today, batch-based data pipelines closer to domain experts is just an unbelievably important storyline to actually like democratizing data throughout companies. I think, and I want you to like tell me if this is true or not, I think that you folks over the past 3 years have been going through this like 8 to 10 year journey of taking a core of something that's great and like building out a real production ready enterprise database. But I'd love to hear, what do things look like on your side? Like what has the team been working on? Like maybe just catch me up.
So the good news is we started this before 3 years ago, right? So I do think the 8-year timeline is real. All the good news is now I want to say we're like maybe 7 years in, right? So it's like right on the cusp of being battle hardened and ready for a wide variety of use cases. And we have a number of customers using us in production. Let's walk through the components, right? So there's a cloud native separated storage layer. There's an elastically scalable compute layer. There's SQL planning, optimization. There's monitoring. There's orchestrating. All of this as a cloud service. All of this is non-trivial to build, right?
Oh, come on. This is a weekend hackathon, right? No, I'm just kidding. This sounds terrifying. Keep listing things and I'm going to get more scared.
And we have, I want to say, lost track of the precise number, 40 engineers, the majority of whom have been building databases, most of whom have worked in distributed systems or databases, either at companies where they've had to operate large microservices or at database companies or distributed systems that they've built. A quarter of them have PhDs. It's no easy feat to build a database, but I think the way to go about doing it is to do it with a long-term time orientation, right? You build a team and you don't create an arbitrary pressure to ship a product in 12 months. You give them the space to build it right. I think a large part of the database companies that have succeeded are those that were correctly capitalized for the task ahead of them. I believe we followed a similar path.
It's exciting. Just the indication of like, we're on year 7 and I'm very excited for what's to come here. And I'm excited to watch the line go up. And I think that all of our friends at reverse ETL companies will be excited for your progress too.
Thank you very much. Yes.
It's definitely been fun to see the product evolve and get more customers using it and learn about these like real-time use cases too. We're going to wrap up. We ask this to all of our guests, but looking 10 years out, what do you hope will be true for the data industry? And Nathan, why don't we start with you?
Yeah, I kind of have 2 things I would hope for, but without a plan, as stated earlier, this idea of streaming versus batch is an implementation detail. So I'm a big fan of, there's this law out there, I think Siegel law, that says a person with 2 watches doesn't know what time it is. So the more we have batch versus streaming or hot versus cold paths, we just now have 2 sources of the truth, which becomes challenging when it comes to influencing and building confidence with your customers. So I'd love for that to go away. The second one is around open semantic layers or headless BI. I'm a big fan of semantic layers, and I feel like that's a ripe opportunity for the industry. Because those business metrics, that last mile, that as well. I got the SQL layer, but now I need to do aggregates.
Now we have to re-record this whole thing. I didn't know you.
Tristan, do you have any opinions on semantic layers?
That's a whole topic area that we just can't get into right now, but that's really cool.
Yeah, so those were my two hopes.
I'm totally going to steal that analogy about the two clocks. That's perfect. I love it. He stole the one I was going to use, which was that streaming should be an implementation detail. So I'll tell you what I want is the return of LINQ. So I don't know how familiar folks are with LINQ. This was a Microsoft query language integrated queries, LINQ. Look, I've made my peace with SQL, and I love SQL, and it's not going away. But if there was one query language that was absolutely breathtakingly beautiful and ergonomic, it was LINQ, and it has gone away, and I want the return of LINQ.
Wow.
I thought you were making a comment about Nintendo release schedules, but now I've got some Google searching to do after we end this conversation. I'm very curious.
An ambitious dream to replace SQL with LINQ, this language that neither Tristan or I know anything about.
Nathan, you were nodding along, so you probably have some memories.
Yeah, and I'm a big fan of PRQL. So it's another kind of example. It's that Flink or Fluent-like way to communicate how you want to be more declarative and how you do your data transforms. I know SQL's declarative, but I think there's another layer above that. And I think we all say that SQL got some rough edges. So how would you kind of do SQL 2.0? Definitely on that list as well.
Okay, we'll wrap there. Thanks so much for joining. Gave me a number of different ways to think about streaming as more of an implementation detail. It's just the tech. Don't be wowed by the tech. Be wowed by how people are using it and who's using it. But this was a really fun episode. Thank you for joining.
Yeah, thanks both. This was a lot of fun.
Thanks very much for having us.
Yeah, thanks.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and Dan Poppy. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.